Today we are working on 3.1. There are only two questions, and they both deal with polynomials. So if we had a graph x plus 1, so this would be x to the first, then that is a linear equation that can hit the x-axis one time. If we have a quadratic equation like x squared minus 6x plus 5, that is a parabola, and it hits the x-axis twice. So this exponent here tells me that the quadratic can hit the x-axis twice. If we were to have a cubic equation, now I don't know what that looks like, but because the biggest exponent is a 3, it could hit the x-axis 3 times. So it could look like this. And then if I had an x to the fourth equation with lots of other stuff there, then that could hit the x-axis as many as 4 times. So 1, 2, 3, 4. You seen a pattern? An x to the fifth could hit the x-axis as many as 5 times. 1, 2, 3, 4, 5. Okay. Now, just because it's an x to the fifth doesn't guarantee that it hits 5 times. In fact, maybe it only hits 1, 2, 3, 4 times. Okay. Or if I were to grab that graph and lift it up, now it only hits 3 times. If I moved it up further, now it only hits twice, and now it only hits 1 time. So the largest exponent doesn't guarantee that the polynomial has that many roots. It just says it could be as many as 5. But it can't be 6. You can never go higher than the than the largest exponents. So we call the largest exponent the degree. And it's important because it gives us an idea of what the shape of the polynomial is. Okay? But what if I had an x to the fourth that was negative? How would that be different from the one that I drew? It would be upside down. So it would still be a W, or I mean, it would still be W shaped, but it'd be upside down when it would look more like an M. Okay? What about all of the signs of all the other pieces? Like, what do all of those do? And what do all of these do? Well, they change the shape of the graph. They push and pull and move things up and move them down, but they don't change the basic shape. Okay? So when we're looking at polynomials, this term is the most important when you're trying to determine the overall shape of a polynomial. The sign will tell you the direction it travels, and the exponent will tell you its shape. And hopefully you noticed some patterns here. So we're going to ignore the ones, because that's not going to happen. What do you notice about the similarity between this one and that one? Do they have anything in common? The exponents are both even. What if I had an x to the sixth? What could you tell me about that? What would it look like? If it hit the x-axis 6 times, what would its overall shape be? Well, if we drew it, we just start hitting the x-axis 1, 2, 3, 4, 5, 6. It's kind of like a triple U. Not a W, it's a triple U. Okay? Well, let's get rid of the negative one. What do this and this and this have in common? They're all even. And what do you notice about the graphs? Positive. So what do they look like? They open up. So in each one of those, the left side goes up and the right side goes up. Left side up, right side up. Left side up, right side up. So if we have an x to an even, then you can guarantee that the graph looks like this. And then something happens on the inside, and we don't know what that is. Could have a whole bunch of wiggles. It might just look like a parabola. We don't really know. But if this is even, then the graph will go up to the left and up to the right. What if we put a negative out front? Then it will be down to the left and down to the right, like this. That is called end behavior. What are the end points doing? Because the stuff in the middle is kind of hard to figure out. That's all of this stuff here. That tells you how many wiggles there are on the inside and how high and how low and all of that stuff, where it hits the x-axis. But the leading term will tell us the general shape. If it's an x to an even, then we either have up, up, or down, down, depending on the sign in front. Okay? What is an x to the 7th going to look like? Right, we're going to start from the bottom, and we hit 1, 2, 3, 4, 5, 6, 7. So notice, if this is odd, then you have one side going down and one side going up. What if instead of a positive, it was a negative? That's going to be the other way, and we start doing this disco move, and I'm not a dancer, so I'm not going to do it. Does that make sense? So if we have positive x to an odd, then the ends will look like this. Left side down, right side up. And then we don't know what's going to happen on the inside. Okay? If we have negative x to an odd, then we're going to have left side up and right side down. Can you guys remember that? So positive odds go up to the right. Negative odds go down to the right. Right? So this would be this is going up. Right? This graph up to the right would be going up, and this graph would be going down. So if your leading coefficient is odd, then your ends are going to be in opposite directions, and positive will go up to the right, and negative will go down to the right. Okay. Let's bring that over, and I'll work a couple problems. Okay. So here's a polynomial. We're looking here at, oh, no we're not. We will be looking there in just a second. So right here, I have positive 6x to the 5th. What does that tell me about the graph? One side's up and one side's down, right? It's one of these. Okay, and the sign in front is positive, so I know it looks like this. I don't know what happens on the inside, but I know that the right side is up and the left side is down. Does everybody understand that? Okay, so we want, it's the first one, right? Falls to the left and rises to the right. Okay, so we look at the next one. X to the 4th. What is that going to look like? It's going to be W-shaped. Is it a happy, is it a W or is it an M? It's going to be a W because the number in front is positive. So rises to the left and rises to the right. Okay. Now the next one is kind of confusing. How many x's are there? There are 4. How'd you get 4? So this x is squared, so that's 2 x's. And this x is squared, so that's 2 more x's. And what number is in front? -4. So the leading term is actually -4x to the 4th. What is a negative x to the 4th going to look like? It's going to be an m. So it would be falls to the left and falls to the right. All right, let's do another one of those. Okay. First one, negative x to the 6th. What is negative x to the 6th going to look like? It's going to be an x to the 3rd type graph that's, oh, sorry. No, it's a triple U. So it's like it's not a double M. It's a triple N. Well, it's upside down. So it's going to be a triple N. So that would be falls to the left and falls to the right. So it'd be this one. Okay, B, negative x to the 3rd. So the left side will be up and the right side will be down, rises to the left and falls to the right. And then the last one, how many x's are there? We count them up. There's 1 there, 1 there, and 2 there. And the number in front is going to be 5 times 3 times 1. So we have a 5 there, a 3 there, and a 1 there. So I get 15x to the 4th. What does positive 15x to the 4th look like? It's going to be a W, so it would be rises to the left and rises to the right. Right there. Okay, think you can handle those? Oops. Okay. So here it just wants to know what is the degree and the leading coefficient. So you find the term that has the biggest exponent right here, and the degree is the exponent, so this is 6, and the leading coefficient is the number in front, which would be a 1. Now sometimes they're going to throw these to you out of order. What would the degree of that polynomial be? 5. And what is the leading coefficient? -7. So that's a piece of cake. All right. That is it for 3.1.